What about other students? Are they coming or not? Okay, we shall start. Last class we discussed about the refraction and related problems. Now we'll go to the another topic today, that is refraction from the spherical surface. Kindly maintain the silence, please. The next topic here, refraction from the spherical surface. A portion of the refracting medium whose curved surface form a part of the sphere is known as a spherical refracting surface, in which we are using two types of the spherical surface. One is convex refracting spherical surface, another one concave refracting spherical surface. It has its own governing formula to find out the position of the object, image, and the radius of curvature. Write down this. A portion of refracting medium whose curved surface curved surface is a part of the sphere. types of refracting spherical surface is convex refracting spherical surface and concave. The sign convention used in this topic are similar to the sign convention used in the mirror. See, this is the part of the refracting surface. It is acts as a concave refracting spherical surface like this. Here, the object will be placed in the left hand side. Consider this is a point object. From here, the incident ray incident on the convex spherical surface. After that, it will be converged. Image will be produced here. This is the pole. The distance from this point is u. This one v. This is the center. Let the object is placed in the rarer medium. Its refractive index, let it be mu1. Here, the refractive index of the spherical surface mu2. Similarly, this is the concave refracting surface. This is the concave refracting surface. For these two refracting surface, the governing formula is, note down this formula. Minus mu1 divided by u plus mu2 divided by v, then mu2 minus mu1 divided by r. This formula is used when the object is placed in the rarer medium and the image is produced in the denser medium. Suppose if the object is placed in the denser medium, comparing to the refractive index of the spherical surface, this formula is modified as, say, instead of mu1, put mu2. Here the mu1 is the refractive index of the rarer medium. Mu2 is the refractive index of the denser medium. When the object is placed in the denser medium, this formula is modified as mu2 divided by u plus mu1 divided by v, mu2 minus mu1 divided by r. The above formula is used for the object when it is placed in the denser medium. This governing formula can be applied for both convex and concave refracting surfaces. This governing formula can be used for both convex and concave spherical surfaces. Note that point. Shall we move?
Yes, sir.
What about other boys, Thambi? உனக்கு தான் தெரியும். உனக்கு தான் கேட்கிறேன். நீ ஒரே பையன் தானே தம்பி? What about other students, boy students? Usually you are coming only one student, huh?
Yes, sir.
Absentees, huh?
No, boys sir, நான் ஒருத்தர் மட்டும்.
அப்படியா? இல்ல previous classes I saw so many students other than you.
7th, sir.
Okay. Next topic here is lengths. Length is a portion of transparent refracting medium. Okay, length is a portion of transparent refracting medium bounded by two spherical surface or one spherical surface. I repeat that definition. Length is a portion of transparent refracting medium bounded by either two spherical surface or one. That is called the length. The lenses are classified as a two type: convex lens or converging lens. Another type, concave lens or diverging lens. It is also called converging. The incident light falls on the surface of the convex. The light will be converged. That is why it is called converging lens. Second one, concave lens or diverging lens. This is the straight line. Sound. The noise is coming from this neighboring class. See, the first lens is called bioconvex lens. This first lens is called bioconvex lens. Second length is called panoconvex lens. Third one, concave convex lens. There are three types of refracting surfaces. In the first length, both surfaces are convex. The second length, there is a straight line. Another refracting surface is convex. Similarly, sorry. This is a concave lens. Bioconcave lens. This one. Another one, plano concave lens, and the third one, convex concave lens. These are the types of lengths. Next one, the formulas are related to the lengths are length maker formula, power formula, and mirror equation. First, take down this length maker formula. This is the important governing formula for the problem related to lengths. One by F is equal to mu minus 1 into 1 minus 1 divided by, 1 divided by R1, 1 divided by R2. Where F is the focal length, mu is the refractive index, R1 is the radius of curvature of the left-hand side portion, and R2 is the radius of curvature for the right-hand side portion. This governing formula can be used for both convex and concave, but the sign convention will be different. When you use this formula for convex lengths, R1 is considered to be a positive. R2 is considered to be negative. For concave lengths, R1 is considered as negative. R2 is considered as positive. These are the important sign conventions. When the ray of light incident on the convex lens, it will be converged. It will be converged. This is the normal drawn from the center of curvature. When you consider the convex portion like this, when the incident light falls on the, it will be a diverged. If it is coming as straight incident on the concave surface, it will be diverged like this. This is a very important phenomenon for this convex and concave legs. Next one, length maker form. Length formula or length equation.
Sir,
Yes.
so length maker formula F by என்ன டிவைட் பண்ணுதுன்னு சொல்லுங்க சார். F and R.
F is the focal length.
R1 sir.
R1 is the radius of curvature in the left hand side portion. For example, consider this portion convex bow. For this portion, the center will be in this direction. Correct? But in the portion, நீங்க பாத்தீங்கன்னா This is a part of that spherical surface. For this, center will be here. This distance is R1. Okay. When you consider this portion, it is a part of the spherical surface. The center of this portion will be in the left hand side. This distance is R2. Why we are taking the plus and minus for R1 and R2? Here R1 is measuring from this point in this direction. This direction is similar to the direction of ray of light. But R2 is measured opposite to the direction of ray of light. That is why it is negative. Understand, students? Please, Amma.
Yes, sir.
Okay.
Yes, sir.
Okay. Next, Pulangla.
Yes, sir.
Next one, length formula. Use the sign convention directly. Sometimes in spherical mirror, we are using 1 plus V plus 1 plus U is equal to 1 by F. Or, sorry, 1 by V plus 1 by U is equal to 1 by F. Here, considering the sign convention, the length formula is modified as 1 divided by V minus 1 divided by U. That is equal to 1 divided by F, where V is the position of the object, U is the position, sorry, V is the position of the image, U is the position of the object, that is the distance. F is the focal length. Okay. Next, linear magnification. Already we have studied this concept in the ray optics law. Spherical mirror. M is size of the image, is the ratio of size of the image or height of the image, whatever it is, I divided by size of the object. It can be equated with V by U. If M is positive, it is a rated image. If M is negative, it will be downward. No, that is why it is an inverted image. Next, how to define the power of the lens, the ability of the lens to converge or diverge the rays falls on the surface. Therefore, a mathematical expression of power is the reciprocal of focal length. That is 1 by F is reciprocal of focal length. The focal length should be substituted in terms of meter. That is very important point. One by F and the suppose centimeter pota, this formula is modified as 100 divided by F. F என்ன பண்ணலாம் சென்டிமீட்டர் நீங்க போடலாம். meter 1 by f, centimeter 100 divided by f. Actually, we have converted the centimeter into meter. That is why 1 centimeter, centi means 10 to the power of -2. Correct, Thambi? இப்போ சென்டிமீட்டர்ல போட்டீங்கன்னா மீட்டர் ஆகணும் என்ன பண்ணணும் 10 to the power of -2 மேல போனா +2 அப்ப 100 ஆயிடும். ஓகே. What is the unit of power of the lens? Diopter. Suppose if the system consists of many number of lenses, to find out the total focal length of all lenses, we have to add the focal length of individual lenses. Say combination of equivalent focal length 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3. It's going on like this. The f1, f2, f3 are the focal length of the individual lengths. To calculate the total power of the combination of thin lenses,
Yes, sir. Finished, sir. Finished, sir.
finished. Okay. Students, kindly see this problem. A double convex thin lens made of glass, the refractive index is 1.5, has both radius of curvature of magnitude 20 centimeter. The incident light rays parallel to the axis of the lens will coverage at a distance d centimeter such that double convex lens. Double convex lens means this is the double convex lens. The refractive index is 1.5. Both radius of curvature is 20 centimeter. Say R1 is 20 centimeter, R2 is 20 centimeter. Understand? The incident light parallel to the axis of the lens. So incident light parallel to the axis of the lens will coverage a distance centimeter such that, what is the question? The incident light parallel to the axis of the lens will coverage at a distance d centimeter such that a double convex thin lens is made of glass, has both radius of curvature, incident light parallel to the axis of the lens and converge at a distance d centimeter such that we have to find out nothing but f. Use this formula. What is the lens maker formula? 1 divided by f is equal to mu minus 1 by R1, 1 by R2. As per sign convention, the R2 should be taken as a negative value, that is minus 20. Here, the mu value is given. What is that? 1.5 minus 1. 1 by R1, 20 minus 1 by minus 20, because R2 is minus 20. Say this one is 1.5 minus 1 is 0.5. 1 by 20 plus 1 by 20. That is 0.5 LCM at the 2 divided by 20. Correct? 0.5 into 2 evaluate. 1. Therefore, F is equal to 20 centimeter. That is the answer.
Completed.
Okay. A substance is behaving as convex lens in air and concave in water. A substance is behaving as a convex lens in air and concave in water. Then the refractive index is greater than air but less than water. Greater than both air and water. Smaller than air, almost equal to water. ஒரு சப்ஸ்டன்ஸ் லென்ஸா யூஸ் பண்றோம். அது ஏர்ல இருக்கப்போ எப்படி இருக்கு, அதை வந்து வாட்டர்ல இம்மர்ஸ் பண்றப்போ எப்படி. When you compare the substance with respect to the air is the rarer medium and the substance is a denser medium. Understand? Next, when you immerse that substance into the water, again that substance is a rarer medium, water is the denser medium. Understand, students? புரியுதா? Consider a substance which is in the air. Compare the refractive index. The refractive index of the substance is greater than the refractive index of the air because air is the denser medium, rarer medium. When the same substance is immersed in water, its quality is decreased. The refractive index of that substance is lesser than the refractive index of the water. புரியுதா என்ன சொல்றேன்னு? ஒரு சப்ஸ்டன்ஸ் ஏர்ல இருக்கிறப்போ ரிஃப்ராக்டிவ் இண்டெக்ஸ் எதுக்கு ஜாஸ்தியா இருக்கும்? சப்ஸ்டன்ஸுக்கு தான் ஜாஸ்தியா இருக்கும். ஏர் வந்து ரேரர் மீடியம். அதே சப்ஸ்டன்ஸை வாட்டர்ல இம்மர்ஸ் பண்றப்போ வாட்டர் தான் டென்சர் மீடியம், சப்ஸ்டன்ஸ் ரேரர் மீடியம். புரியுதுங்களா? அப்போ ஆப்ஷன் என்ன? ஏ தான் ஆப்ஷன். The refractive index is greater than air but less than water. Understand? Let us go to the next problem. A convex lens of focal length 20 centimeter made of glass, refractive index 1.5 is immersed in water. Having the refractive index 1.33. The change in focal length of the lens is 62.2 centimeter, 5.82 centimeter, and a 58.2 centimeter, and last option 6.22 centimeter. I read the question. Convex lens of focal length f 20 centimeter made of glass of refractive index mu 1.5, which is immersed in water having the refractive index 1.33. The water refractive index is lesser than the lens in this case. What is the change in focal length of the lens? What is the change in focal length of the lens? That is the question. Here, the problem consists of two cases. First one, the lens is in air. In the second case, the lens is in water. And then let us compare these two equations and find out the change in focal length. when the length is in air, the first case, length is made up of glass. The formula is 1 divided by R1 minus 1 divided by R2. Substitute the value. For the first case, the focal length is 20. The refractive index of the glass is 1.5 minus 1. And then focal length are not given. Consider this is the first equation. The same length is immersed in water. First, the length is in air. Second case, the length is immersed in water. Here, actually, in this formula, here the denominator is refractive index of the air. We have deleted that value because it is 1. But in the second case, both the medium, that is the water, and the refractive index of the glasses are given. Therefore, the formula is modified as the focal length of the water when it is immersed in water is not given. And then this can be written as 1.5 medium of water is not given actually. 1.33, yeah. Oh, right. This is the second equation. Now, students can do this one. Divide the equation 2 by 1. Divide the equation 2 by 1. You can find out the change in focal length. Because all of you listen here. When you divide the equation 2 by 1, the right hand side portion 1 by R1 minus 1 by R2 get cancelled. The remaining portion will be the front part of that value 1.5 minus 1 and 1.5 divided by 1.33 minus 1 will be remaining. Here, the FW will come in the numerator side. Can you solve it and tell me the answer, please? One by two போட்டாலும் சரி 2 by 1 போட்டாலும் சரி 1 by 2 போட்டீங்கன்னா தான் அது வரும். சாரி 1 by 2 போடுங்க. அன்னோன் மேல வந்து This is 1 by 20. Here, the left hand side, in this case, FW divided by 1. Then the right hand side here, 1.5 minus 1, 1 by R1 minus 1 by here 1.5 divided by 1.33 minus 1, 1 by R1, 1 by R2. These two things get cancelled. Again, the left hand side, FW divided by 20, 1.5 minus 1 is 0.5. In the denominator, if you take the LCM 1.33, 1.5 minus 1.33. It can be written as and then after solving this, simplifying this, you can find out FW. Tell me the answer, please. Just cross multiply 20. Any one of the students can tell me the answer. After simplifying this. பண்ணியாச்சா 20 into 0.5 10. 10 into 1.33 is 13.33. 13.33 divided by 1.5 minus 1.33. How much? சொல்லுங்க தம்பி. எவ்வளவு நேரம் ஆகுறீங்க? 1.5 minus 1.33. 0.17 இல்ல? Answer, what is the answer? 70 78 point. What happened? Network problem. Have we finished that? Purila Thambi? What is that answer? 78.2. The question is find out the change in focal length. Already we have 20 centimeter. Hello, can you
Yes,
hear
sir.
me?
Yes, sir.
If answer என்ன வந்திருக்கு உங்களுக்கு 78.2. 78.2 already இருந்தது வந்து 20. அப்போ we have to subtract that value. 78.2 minus 20. That is the answer. That is change in focal length. Change in focal length. 78.2. The given is 20. Therefore, the answer, final answer is 58.2 centimeter. Students, kindly note down this. The change in focal length is 78.2 minus 20. That is equal to 58.2. That's all. That's all from today. We will see you in the next class. Thank you very much for attending the class. We'll see you tomorrow. Thank you.